Hello, our most developed student. My name is Confident and welcome to our 24-minute lesson. This is the ultimate guide in maths, science, career guidance, as well as a sneak peek in my personal experiences. This is a channel that is designed with you in mind. Let us dive into today's lesson. The first thing that you need to be aware of is the definition of terms, and when we're dealing with energy and momentum, let's start with the first one, which is momentum. If they say define momentum. Now, if they say define momentum, what I'm going to say, it is the product, that's the first part, is the product of the mass and velocity of an object. So don't forget that it is the product of the mass and velocity of an object. Now momentum P is equal to m times v, so you can get the definition here to say it is the product. Product means times, that's the definition there, product of the mass and velocity of an object. The next one that you need to know when you're looking at the definition of terms is kinetic energy, which is called EK. Now, what is kinetic energy? It is the energy of the object due to its motion. The energy of the object, and the keyword there is due to its motion. Right, so they will give you formulas here to say what is EK, and then on the formulas, the kinetic energy is half mv squared. You know, m is the mass and v is the velocity of that object. And then I would say lastly, the definition is potential energy, which is EP. And then again here, it is the energy of the object due to its position above the ground or above the earth. The energy of the object due to its position above the ground, which is above the ground. So don't forget these definitions. And then when you come to the formula now of EP, we're saying EP is again given is mgh, which is mass times gravity and then times height. This is the height above the ground. I will explain what it means, especially when it comes to this. So these are the, as I'm saying, I'm just laying a few things here on the definition. Now there is something, for example, let's put a let's say we have a diagram here just to bring again some concepts. You have a diagram that is whether it can be anything, a diagram, a tree, or just anything. This can be, can be a tree, a building, or anything. But what is important is let's focus on an object that is above there. And then when you are having an object that is above, now we must accept the reference point, or where we are looking at. We are looking at this object from the ground. So there is our ground, and then if this is the ground here, that is our reference. Remember, when we're talking about potential energy and kinetic energy, we are saying this object is falling down. All right, so when this object is falling down, again, first things first, what is the object at the top? This is the top. What is this object possessing? The first one is that this object is possessing potential energy, EP, which is equal to mgh. You can see that. But here, remember, kinetic energy is 0. Why? Because this object is not moving. It is stationary. So if you say stationary here, V is equal to 0, and kinetic energy, don't forget the formula, is half mv squared. So if V is equal to 0, meaning EK here is also equal to what? Is also equal to 0. So the object at the top has no kinetic energy. That is what they're trying to get information from you. Do you know that at the top, before the object starts falling, the kinetic energy is equal to 0, but it possesses potential energy, and this is the maximum potential energy. Why? Because we are saying this object, if you look at the distance above the earth, which is the height of the object, if I do that and say what is that distance, this is the maximum distance above the earth. See that? So if this was the distance, the height above the earth, so this is the maximum height. So if this is the maximum height, it means also we have the maximum potential energy. And then we come to the bottom. Let's say this object has fallen down, for example, somewhere there. Let's say this object is now somewhere there. Now at this stage here, it also possesses something that is unique. Number one, it has EP and it has EK. It has both. Why? Because it is still above the ground. You can see that this is the distance above the ground there. Let me just look at the distance above the ground. So this object, if I can use this line here to say this object still has some distance above the ground. So meaning, if you are looking at your edge here, don't forget you are looking at edge above the reference, above the ground. Forget about this height when you are dealing with potential energy. So if you are dealing with EP, but if you are dealing with EK, you need to consider this particular height here. So here, that's your EK, meaning what is the kinetic energy after falling from the what? From the top. So you have to consider the height that it has fallen. But when you're considering the potential energy, this is where you are looking at the energy of the object above the ground. So you look as your reference point, start from the ground going up and ask yourself, where is that object at that point? That is where they are trying to catch you. And then lastly, at the bottom here, see at the bottom, now just before it hits the ground, they will also ask you to say what is the potential energy. Don't forget, this object doesn't have any height now above the ground. So if the ground is here 0, potential energy is 0. Why? The height above the ground now is 0. But this object EK is equal to half mv squared. This is the maximum. Sorry about that. It's squared. So this is our maximum what? This is our maximum kinetic energy. See? So at this moment, the kinetic energy is at its highest. So you can see two things. The potential energy is at its highest at the top. The kinetic energy is at its highest at the bottom. So it simple means they can come up with a formula to say energy at the top is equal to energy at the bottom. See that? That is the conservation of energy there. Meaning if I say, remember if I say ET, that is total energy, it's kinetic energy of an object plus its potential energy. That is the total energy. Now, if I can say then here, you need to remember this. At the top here, so I can come back on this one and say at the top it will be EK plus EP, where at the top, see that, which is equal to EK plus EP, where at the bottom. You see that? So now we agree again to say at the top we know that the kinetic energy is 0, and then at the bottom the potential energy is 0. So meaning you can come up now with the conclusion that EP at the top is equal to EK at the what? At the bottom. So these are the few scenarios that I want you to always get used to. So just remember that. And then also there is a few things that you need to know in your mathematics. If I say what is EK, you know that EK is equal to half mv squared, and you need to know how to calculate velocity there. You understand? So to calculate velocity, first things first, you need to first multiply by 2 there. you multiply by 2 so that you can get rid of that half. So you've got 2 times whatever EK they give you is equal to mv squared. You see that? And then from there, you don't want that m, remember it's multiplying, you divide by m, you divide everything by m, there it is. So now at the end, you are having 2 times the EK you would have calculated over the mass is equal to v squared. Now if you want the velocity, that's where you square root everything both sides. Okay. Secondly, you have a formula that says v squared is equal to u squared plus 2as. You must not forget that the a there is the g, the acceleration due to gravity when an object is falling. So v squared becomes u squared plus 2gs. And then don't forget the u squared at the beginning, there is no velocity, so it's 0. So you've got v squared is equal to 2gs. Why? We said at the top this object has got 0 velocity, so v is equal to 0 at the top. That is the initial velocity. So if you want to find v, you square so that your v is equal to square root of 2gs. Sometimes you find a question being answered like this in the memo is because they have already made v the subject of the formula. So that is that. Now let's look at practical questions that you can find in the exam. As I said, I'm doing this for one of my students. So there is momentum, says define the momentum. A student asked about energy and momentum. So define the momentum of an object. Remember, we said that it is the product of the object's mass and velocity. P, you remind yourself of the formula. What is it? P is equal to m times v. So you just say that times is the word product. So it is the product, you start with it, the product of mass times the velocity of an object. So that is that. Now the most challenging questions I think there for you guys is the questions with calculations. 3.2. It says an avocado with a mass of 150 grams hangs from the avocado tree. It then falls freely from 70 meters above the ground level. Calculate the following. So let's come up with kind of a sketch here. You are saying there is a tree here. Alright, so this particular tree of ours here, so we have, always remember, you need the ground. So there is our ground here. Right. So when we have the ground, we are saying there is an avocado. Let's take the avocado was falling from there. There is your avocado there. So they are saying an avocado with a mass of 150. So you need to have that information, very important, as you are given. Now always work with the SI units. You remind yourself to say m is 150 grams, but you don't deal with grams. M you divide by 1000, which is 150 over 1000. So m is equal to 0.15 grams, right? So you come here to say m is 0.15, not grams, actually kilograms. Now sorry about that, you work with kilograms. So 0.15, we know that now it's in kilograms. It says hangs from an avocado tree. It then falls freely from 70 meters above the ground level. Above, so you look at the ground and we are saying the distance from the bottom, that's why they're saying above. If I do mark this, let's say this is our avocado here. See, I just want to make it a little. So this is avocado. So the distance from the ground going to that avocado there, they are telling you that distance is what? Is 70 meters. Alright. So you need to be aware of that information. And then says calculate the following. Number 3.2.1, 2 marks. The potential energy after falling 20 meters from the avocado tree. Look at the keywords there. They're trying to confuse you there. They're saying the potential energy, which is our EP. Are you with me? And then it says after falling 20 meters from the avocado tree, which means you go to the avocado tree and then you say to yourself, all right, it fell from, so it means from here it was falling, and it fell how many? 20 meters. Let's say this was 20 meters, like that. And then let's cut it here also, like this. But now the question is the potential energy. When you are finding the potential energy, you come with the formula to say EP is equal to mgh. Just check your formulas, you will have this, meaning mass times gravity times height. Now I want to emphasize this part. What is this h? Don't be tempted to say, okay, since this is 20 meters falling down, and then you're saying your h is 20 meters, they would have caught you. That is not correct. Remember, what is h? H is above the ground, above the ground. So which means start from the ground. Whenever you're dealing with h, start from the ground and ask, what is the distance from the ground to that point where it has fallen? What? 20 meters. Do you see what is happening here? So which means you know that for me to get that, it's 70 minus 20. So meaning the distance above the ground is at 50 meters. Picture the avocado now being there, and we are looking at above the ground. Potential energy says your reference is start here, start there. You see, then when you're writing, you're gonna have EP is equal to mass, which is 0.15. We already converted it, times G. If you check your information sheet at the front of the paper there, they will give you your G, which is 9.8 times. Now that's where you use 50 now, not 20. But also it's fine to come and show the formula here to say when you've got 50, you say times, you can use 70 minus 20, which is showing now how you got that particular 50. Are you with me? And then when you come to EP is equal to, then you can now conclude and say, what is my EP? Which is 0.15 times 9.8 times 50. Alright, equal to, and then you've got 73.5. It's 73.5 watt. Energy is in joules. Don't forget the units. Energy is in joules, J. That is the first question. The second question is the velocity of the avocado, 15 meters. Look at the keywords there. The velocity now of the avocado, which is our V, 15 meters, yes, now is above the ground, above. So which means our reference is the ground. So I come on the ground and say, if I'm moving 15 meters above the ground, so I'm here to go 15 meters above the ground. Let's say my 15 meters is here, and I'll divide my line like that. So this is my 15 meters. It's above the ground. But now when I'm dealing with velocity, remember this object is falling from the top. So it's starting here. So which means potential energy reference is the ground, but the velocity, the reference is the top. So you ask yourself, from the top, how many meters has it fallen? That's where they are trying to just twist your idea there. So velocity, you start from the top there and ask yourself, if it is at 15 meters above the ground, there is the object, is somewhere here. So how many meters has it fallen? So you can see that if you subtract, it's 70 minus 15. That's the meters it has fallen, which is what? Which is 55 meters, right? So that's where they're trying to catch you there. And then if you are looking at velocity, remember the formula that you have. You've got two formulas that link velocity. We have got EK as half mv squared, and then you've got v squared is equal to u squared, which is initial velocity, plus 2as. These formulas are the most common formulas you're going to use. Now usually when you're looking for velocity, this is the one that you're going to focus on. Now the good part is u initial velocity. Remember, we are saying it fell from the top, so here velocity is equal to 0, hence we said kinetic energy. Here EK is also equal to 0 at the top, remember. So we come here and say, since we know that initial velocity is 0, we have got v squared is equal to 2. Now a is g because it's falling freely, which is the acceleration due to gravity is what is working on. So it's 2gs, and then s is the height from. Now this one, always remember, from top, not from bottom. Now kinetic energy from the top, okay, height from the top. So v squared is equal to 2, then they'll give you your g, 9.8, and then we said it fell 55 meters. But you can write it, as I said, it's also fine here to say 70 minus what? They said it fell, is it 15 meters? Yes, 70 minus 15 here. You can just show that working. So what then becomes our v squared? Remember, I'm still calculating v squared, which is 2 times 9,8 times 55. And then I've got that 1078. So this is 1078. Guys, don't be tempted now to say this is the answer. No, this is v squared. Now to get v, you square it both sides. Then you've got your v after squaring both sides. Then it becomes square root of 1078, and then you get that is 32,83 to 2 decimal places, which is 32,83, but don't forget it's meters per second. That's the velocity. All right, then the next question, the kinetic energy of the avocado just before, listen to this now, the kinetic energy of the avocado just before it hits the ground. Now kinetic energy, what are they looking at? There is our EK there, that is the formula. But just before it hits the ground, you are looking at it now at the bottom here, just before it hits the ground. Guess what? Potential energy is now 0. Then you use that formula to say EK at the top is equal to EP. Sorry, I wanted to say here, that's my P. The potential energy at the top is equal to EK at the bottom. Remember, it's converting potential energy, which was at the top, becomes kinetic energy. So here you have got EK at the bottom. At the top, what do you have? You just have EP. Here is EP. So that's the conservation of energy there. So now the question is saying we need to calculate what? The kinetic energy at the top, at the bottom. So if I can find my EP at the top, I will automatically find my kinetic energy at the bottom. So what is my EP? It's M times G times H. Remember that. Which we did, we didn't calculate it. We didn't calculate that. Which is equal to M was 0,15 times G was 9,8, and then times the height. Remember, when it's at the top, it was 70 meters above the original height. From the question, they said 70 meters above. Then that's the one that you use as 70. And then you're going to calculate now the potential energy before falling. This is what we're calculating. The potential energy before it starts falling. 0,15 times 9,8 times 70. See, I'm using the original distance before it fell, which is 102,9 joules. So this is the energy before it fall. But don't forget, it's the same energy it lost at the bottom now. So it was falling from the top, that energy, it lost it at the bottom. That energy was now kinetic energy. Then you can say, therefore, EK is also equal to 102,9 joules. That is the one way. Another way you could have done, which is still fine, you find the velocity at that bottom. Since that formula is EK is half mv squared, we can actually find the velocity here. Let's find V. Actually, to find the V or the V squared, look at this. The formula says EK is equal to half mv squared, and then I've got V squared is equal to U squared plus 2AS. So I can actually focus on finding v squared. Then I can do that. You see that? So now this formula can find me v squared. V squared is equal to, remember, u is 0 plus 2, and then my g is 9,8, and then my s, which is what? At the bottom now, the distance it has fallen, it was from 0 to 70 meters. Still the same distance, so you put 70 there. So that is my what? That is my v squared. So my v squared is equal to, I can do now that and say 2 times 9,8 times 70, and then it gives me 1372. So that is 1372. That is my v squared. Then I take it there in the kinetic energy. Ek is equal to half times 0,15 times the v squared, which is 1372. You don't need to square root here because you'll need it again, you see. That's why I avoided that. And then if I do that, it will give me here 1/2 times what? 0,15 times 1372, and then equal to, and then I'll get 102,9 102,9 joules, which is the same answer I think we got here, 102,9 joules. So this is that, guys. Depends how you want to approach it. All right, let's look at another one. There is another question. Define kinetic energy. Here we did define the energy an object possesses due to its motion. And then question here, they're saying a brick with a mass of 10 kilograms falls from a building at a height of 15 meters from the ground. The brick hits a platform 3 meters from the ground, and then calculate the kinetic energy as well as the momentum of the brick as it hits the platform. Again, a question here that it kind of brings, I think I can do it here. Let's look at this. It's just simple. I'm just giving you a simple sketch. There is a building here, and in this building we are told a few things. How tall is this building? This is our reference point here. This is the ground. Alright, then this building from the ground, they are saying it is 15 meters. Alright, I just want to try to make it fast. 15 meters is the tall of this building, and then they are telling us here with a brick with a mass of 10 kilograms. So let's say this was the brick here. See, there is our brick. So now it's 10 kilograms. Now look at the units, it's already fine. You need to work with kilograms, don't forget. So if they give you grams, you divide by 1000 to convert to kilograms. So now we have already been given kilograms. Even the distance must be meters. If they give you any other distance, convert it to meters. Now they are saying the brick hits a platform 3 meters above the ground. So let's come, it says 3 meters from. Always remember the words from. So I come here and say there is a certain platform that was here, like a thing like that, like a platform thing. So when this brick was falling, let's make it long. Okay, I'll make it a bit long. So there is the platform. This brick was falling, it hits this thing here. You can think of whatever it is. So it's falling, and the brick comes and hits that platform here. But now they told you, what is this distance? The distance of this platform here is what? From, it's 3 meters. So automatically when you do such, you need also to be quick to say, but I have that distance also. What is this distance now left? You know, because they won't give you things without order. 3 meters, so you expect this one to be what? 12 meters now. Because 3 and 12 gives us the 15. Now look at the calculation. Calculate the kinetic energy. Now you come back and say, okay, with this information I have, Ek, you write the formulas. Ek is half mv squared. But don't forget, whenever you're dealing with these, you cannot ignore the EP. Is at the top. Here we know what is EP. The EP here, EP is maximum. So when it starts falling, it's losing EP as well as converting it to what? To kinetic energy. But anyway, let's leave it like that. But since they want kinetic energy, you can come here and say, I know the other formula for kinetic energy, which is that one. 2, remember I said already, you just put G. The formula says 2AS, you put G. Now, initially, U here equal to 0. It was not moving. Initial velocity is 0. So V squared is equal to 0 plus 2G is 9,8. And the distance, look, the distance now, don't use 3 meters because it's from the ground. It was falling on top towards the ground. So it came down here and it's somewhere here now. You see that? So where is it? It's 12 meters now. Don't use 3 meters. It's 12 meters from the top. And then, which is V squared is equal to 2. Let's multiply that. If you multiply that, what you get is 2 times 9,8 times 12, right? Equal to, and then you've got 235,2. 235,2. Now this is V squared. Usually leave your answer like that. Avoid coming back to say, let me show you. Some they will say square root of V squared is equal to square root of 235.2. See, now when you do that, it's still fine, but I'll show you. V is equal to, I'll show you that you are working in circles. If you find that V squared, you will be working in what? In circles. It's not necessary, but let's do it. Square root of 235,2. Now we know that our velocity is 15,336, which is 15,34. So it's 15,34. This is meters per second. We've got our velocity. But the question never required velocity. It says what? Kinetic energy. Then you come here and say, okay, I'll take it from there. My EK is equal to half mv squared, which is equal to 1 over 2 times m was 10, remember the velocity, times, now look, v squared, I'll come here and take this as v squared, which is 15,34 squared, but I should have actually used this value once, which is 235, you see. Instead of that, you can actually come here and say, instead of squaring that again, you are wasting time here because you are going to square it, and if I come back and square this 15,34, I say squared, it takes me back to 35,3. Now you see it's even a bit changed because you rounded off, so it's better to say, if I'm here, I can avoid this one and write equal to EK equal to half times mass is 10 times the v squared is that one, which is 235,2. See that? But that one will still be fine, nothing wrong, just that you are just working in circles there. And then you get your answer as 1 over 2, see, times 10 times 235,2. And then what do you get? 1176. What? Joules. That is one way. Now the other option you could have done was to focus on the potential energy. We said this brick here is having EP, remember, its maximum potential energy. Now it is falling down. So as it is falling down, where it is now, it has fallen 12. Look at this. It has fallen 12 meters because it's somewhere there. It has fallen 12 meters. Are you seeing that? Now because it has fallen 12 meters, which now it is there, you can come here and say EP being mgh, that's the formula for EP, and then you can find the potential energy this particular object has lost. Remember, potential energy is at maximum, so we want to find the EP here, the potential energy here at this point, right? But we know, of course, that this is 3 meters. So what you can do, two options that you can do here, you can say, okay, let me use this 3 meters to say initially what was EP max. You can find EP max. EP max was m, which is 10 times G, 9.8, times the height, it was what, 15, right, which is equal to, we can find the maximum potential energy it was having, which is 10 times 9.8 times 15, which is 1470 joules. This is the maximum potential energy it was having. So now we can have now EP at that 3 meters, just want to show you, is equal to 10 times 9.8 times 3. And then we can now find that potential energy at that 3 meters. So it is 10 times 9.8 and then times 3, which is equal to 294 joules. Now if you look at this, when I subtract these two, so it will be that potential energy there. So if I just subtract the two and say 1470 minus 294, you'll see that I'm getting what, 1176, which is equal to 1176 joules, right? And 1176 is the one that we got here, right? But simpler, without having all this, you just come and say here EP, you just say EP is equal to mgh, which is equal to 10 times 9.8, and then you just say times what, the distance, which is 12 meters, because that's the distance of the potential energy lost. Then if you do that, you'll see that it will give you the answer straight away. 10 times 9.8 times 12, and then it gives you 1176. You see that? So I'm just giving you options of how you could have approached this whatever way, but you know that that EP, you conclude to say EP lost is equal to EK gained, because we are not calculating EP, then which is equal to 1176 joules. So you can say now EK is equal to 1176 joules. They're still making correct on that. Alright, and then they say calculate the kinetic energy as well as the momentum. Momentum now, you know, P is equal to M times V. It's the product of the mass and the velocity. Now, at what? Remember, they are still talking about this point. So, fortunately enough, it now forces you to have gone through to say, you look at, remember I said there was no reason for you to do this. So you come and say V squared is 235,2. You come here and say V squared is equal to 235,2. Then that's when you square it. Now, see, it needs that square. So V is equal to, you write the same answer you got here, 15,34. See that? 15.34. Then you've got P is equal to 10 times 15,34. Remember, mass times velocity, which is equal to 153,4. Now look at this units. M is in kilograms, right? Velocity is in meters per second. So it's just kilograms, meters per second. So this is what you guys are supposed to be doing whenever you're dealing with this energy and momentum. Now, for me, I want you to do this question for me. Just pause and look at this question. It also required a different approach, but it is something that you can try it on your own. Give me feedback and tell me how is it. Here, they already gave you something like an object freely falls from a height. Okay, you got the height, and then the kinetic energy. See, they give you EK here. And then just before that, now they want you to find the velocity. Now you know the formula for EK there is 1/2 mv squared. So here they gave you this here. Then you're finding that the mass of the object. You can come back to say, actually it's a bit tricky here because you don't know the mass. Okay, you don't know the mass. So EK at the bottom, use EP version. Remember also EP is mgh. That's another one. EK at the bottom is EP at the top. So you can even use this one. You know the height. Now you can find M. It can give you the M. So this is that part that you could have used. And then here you could have used V squared is equal to U squared plus 2GS. That's the one that could have given you V there. because at the top this one is 0, you know g, you know height. So just play around. So for this one, on the mass of the object is this question, on this one is this question, and then the potential energy, see they're tricking you 1 mark. Potential energy is the same as that, you know, and then the momentum P is mv. So try this question, see whether it gives you an answer, and then give me feedback. Now we've come to the end of our lesson. Remember to subscribe and ensure your notification bell is turned on, and more of these you're going to be able to follow up. Thank you.